Hi everyone, it's Mrs McInnes here. Welcome to lesson 2 of Similarity. So in this lesson we're going to be looking at similar areas. Okay, so shapes that have similar lengths also have similar areas. And when we calculate similar areas, what we do is we first of all find the scale factor, so as we learned in the last lesson. And then what we do is, because area has 2 dimensions, we then have to square our scale factor before we multiply that by the area of the first original shape to find the area of the new shape. Okay, so what we do is we just find the scale factor as we were before. So if it's enlargement scale factor, it's big over small of the pair of sides that correspond. If it's reduction scale factor, it's small over big. And then all we do is we square it for area scale factor. Okay, then what we do is to find the area of the new shape, we just multiply that area scale factor by the area of the original shape. So let's look at a couple of examples. So here we have example 3. We have 2 semicircular objects that are mathematically similar. The larger semicircle has a radius of 14 metres and an area of 308 metres squared, while the smaller semicircle has a radius of 7 metres, and we are being asked to find the area of the smaller semicircle. So we would start off as we would normally with the reduction scale factor, because the area that's missing is on the smaller of the 2 pictures. So obviously we have 2 measurements that correspond together, the 7 and the 14. We have 1 on each picture. So reduction scale factor is the small number over the large number, so 7 over 14. So that simplifies down really nicely just to 1/2. So then we would do our area scale factor. So all we do is we square our reduction scale factor, so 1 over 2 squared. So when you're squaring a fraction, you square the top number and you square the bottom number. So 1 squared is 1, 2 squared is 4. So our area scale factor is 1/4. Then to find the missing area, we would just multiply our area scale factor by the area of the original shape. So 1/4 times 308. And that is going to be 77, and then the units for this is metres squared. And that's it, that's that question complete. So very similar to the similar lengths questions that we were looking at, we just have this extra line in the middle here of our area scale factor. So let's try example 4 now. We have here 2 skull-shaped fridge magnets that are mathematically similar. We're told the smaller magnet has a height of 6 centimetres and an area of 22.5 centimetres squared. The large magnet has an area of 15 centimetres, and we're being asked to find the area of the larger magnet. And this question is also to 1 decimal place. So we're looking for the area of the larger shape. So we'll start as we were before with doing enlargement scale factor. Our pair of measurements that correspond together would be the 6 and the 15. So for enlargement scale factor, it's the bigger number on top, so 15 over 6. And then that simplifies down, they both divide by 3, so 5 over 2. So area scale factor is our next step of working, so we're going to square our enlargement scale factor, so 5 over 2 squared. So we square the top number, so 25, and we square the bottom number, so 4. So 25 over 4 is our area scale factor. Lastly, to find the area, we're going to multiply our area scale factor by the area of the smaller shape. So 25 over 4 times 22.5. So we would get for this 140.625. So to 1 decimal place, it would be 140.6 centimetres squared. Okay. So the questions for this lesson are as follows. From page 20, it's question 1, 2 and 3. So it's the full exercise from that page. It's page 20, and I think it goes on to page 21 as well. Okay, if you have any questions, I will be on the live call today on the Teams page, so please pop on and ask me anything that you are needing a wee bit of help with. Okay, thanks for listening guys, and I will speak to you on the Teams page. Bye now.